Let's come back and start your 2017 paper. So in 2017 paper, let's read the question again. Draw the structures of the following. Okay, as I said, every question paper they will give you draw the structures and reasoning questions. Please, that is the reason I've done so many videos with the structures and reasoning questions. Go through all the videos. So they've given us to draw the structure of H2SO3, which I did in video number 99, and HClO3, which I did in video number 100. Done. Oxacids of sulfur and chlorine. That is your halogen. Now they've given us one more question. Give reasons for the following. Red phosphorus is less reactive than white phosphorus. Okay, I taught you one. I've given you one differences between red phosphorus and white phosphorus. Now they're asking you to write in one word. How to write? Basically, when I speak about red phosphorus, it is less reactive. They said. What is the structure of red phosphorus? Red phosphorus basically is a polymeric structure. Go through that video where I've shown you the structure of red phosphorus. The P4 units, one P4 unit is again linked with one more. In this way, they form polymeric units, right? So the main reason red phosphorus has polymeric P4 units. Done. So when it is linked one after the other, it is obviously less reactive, isn't it? We require more energy to break it. So if the bond dissociation energy is less, then only it is reactive. But here, because of the polymeric P4 units, it is less reactive. And when it is white phosphorus, why is it more reactive? In white phosphorus, you have only one tetrahedral unit. So that tetrahedral unit is discrete. It is fixed and arranged. So right now, red phosphorus has polymeric, means many units linked together. Red phosphorus is tetrahedral discrete structure, discrete molecule or discrete unit. That is would be better because I wrote unit also here. That's it. Because of this structure, red phosphorus is less reactive than white phosphorus. And next important thing, they've given us electron gain enthalpies of halogens. I've already did this video in video number 88. And the next one more question, N2O5 is more acidic than N2O3. This video I did it in video number 11. Please watch the video for the required information. Right, let us come back and solve your 2016 paper. In 2016 paper, what do they give me? They've again given the structures. So structures I've already done in video number 97 for the interhalogen compounds.
Academy, the biggest online platform, learning platform in India. Let's crack it. I'm Vani Potepalli, the verified educator for grade 12 students, CBSE, ICSE as well as state board students are with me. The upcoming classes which I'll be going to take are aldehydes, ketones and carboxylic acids. Along with that, solutions chapter would be done and a revision series on board examination and how to crack board 2021. I'm going to give you a clear analysis of the revision series. And in the special classes, I will be taking 3 sessions continuously. That is how to learn chemistry in Telugu. It will be on the respective dates. And I'll also be taking a special class where you can plan it and you can just meet me on December 21st and 22nd. I'll be discussing what is the revision series, what is the revision strategy for board exam 2021. These are the Unacademy Plus subscription features where you have daily practice sessions, mock tests which are going on, live quizzes which will be going on, subjective test series coming soon. Join us. Unacademy iconic subscription features include personal mentors. You have live doubt clearing sessions. Weekly reports will be sent to the parents. Parent Connect, where the report will be sent to the parent and the educators are in contact with the parents too. A study planner is perfectly planned and all benefits of Plus also will come under iconic subscription. This is the class 11 subscription. Don't forget to use my referral code, that is Vani10 or Vani Life. So the subscription rates you can go through. Grade 11 iconic subscription prices, that is again Vani10, Vani Life. Note my referral code. Next comes your grade 12 subscription where prices are given. You have an option of 3 months and 6 months. Please try to use the code Vani10 or Vani Life to get the 10% discount. Then comes the grade 12 iconic subscription, 6 months, very less amount. So you can take that particular thing, use my referral code Vani10 and Vani. Unacademy introduces doubt solving batch for final examinations. That's for science and commerce students. So this is going to start on 21st December. It's a duration for 2 months. You have all the main subjects covered: physics, biology, maths and chemistry. The timings are mentioned. Please go through. We have also introduced prime batch for commerce final examinations. That's for class 11 CBSE 2021. You have all the subjects like business studies, maths, English, accountancy, and economics, which is covered, which is for a duration of 3 months, and the end date would be March 5th, and the starting date would be December 21st. Please note, start date would be December 21st, end date is March 5th. We have also prime batch for science final examination. This is going to start on December 21st. End date would be March 5th. It's a duration for 3 months. All the main subjects are covered like English, maths, biology, physics, and chemistry. Doubt solving batch for board examinations, science group has started already. The batch is for grade 12 students. That's for CBSE grade 2021. All the main core subjects, that is physics, biology, maths, and chemistry, would be dealt. It's going to start on December 21st. That's a duration for 2 months where sessions are going on. Whatever doubts you have, you can just come and get it clarified to score that 70 out of 70 students.
Then I also did this XCF4 structures, that is group 18 elements, under video number 52. Please watch the playlist. Then we have one more question. What happens when SO2 is passed through aqueous solution of Fe+3? Done. Here I have taught you the different oxidizing properties. So that comes under video number 78. There is oxidizing property of sulfur dioxide. Watch that video. I've listed out many examples for that, right? So next question, XCF4 reacts with SbF5. Okay, simple question this is. XCF4 plus SbF5. Simple. It's going to form two complexes. Just see. One fluorine from here shifts to this. So this becomes XCF3 minus 1. Because this is accepted, this becomes SbF6 plus. That's it. This is the complex. Done. SO2 is reducing while TeO2 is oxidizing. Why? Okay. So when I have to see from sulfur to tellurium, when I go down the group, which oxidation state is more stable, higher or lower? So when I see sulfur, the stable oxidation state is +6. This is stable. And in tellurium, the stable oxidation state is +4. Now see, when it is +6, when I say it is +6, that means it can lose electrons. When it can lose electrons, that means, isn't it reducing in nature? Reducing, isn't it? Now here, +4 oxidation state compared to this is less. So this is oxidizing. So how should you write? Down the group, stability of higher oxidation state decreases. Okay, decreases. When it is higher, it has lost. That means reducing. For sulfur, already they said SO2 is reducing. So higher oxidation state decreases. For example, sulfur, the stable oxidation state is +6. +6 is stable. For tellurium, stable oxidation state is +4. +4. Done. So this shows that SO2 is reducing and your TeO2 is oxidizing. Done. So I've written the same here, oxidizing. So simple. Whichever has higher oxidation state, that means it has lost electrons, 6 electrons. When it is losing electrons, reducing nature. Here compared to 6, 4 is less, so it is oxidizing in nature. So write this down. Down the group, stability of higher oxidation state decreases, means lower oxidation states are more stable. It will not tend to lose electrons. If it is not losing electrons, it is oxidizing. This one, isn't it? So remember, did I say something? +6. Okay, it's correct only. So remember, higher oxidation state is reducing, lower oxidation state oxidizing. Now let us come back. N2 does not form pentahalides. Okay, why is N2 not forming pentahalides? They said. What is the reason? When something has to form pentahalides, it should possess d orbitals. So simple, nitrogen does not possess d orbitals. When it does not possess d orbitals, automatically we can say that it does not form pentahalides. Done. ICl is more reactive than I2. Okay. Why is this more reactive? When I have to see the bond between these two. So ICl bond, and when I compare these two, ICl bond is weaker. Interhalogen compounds bond is very weak. So ICl bonds are weaker compared to II bond. So when the bond is weaker, automatically they are reactive, isn't it? Hence are reactive. That's it. Simple. 8 marks answer. Simple. Like, if you write the concept and write the keyword, automatically you will get the mark. Right, let's come back and solve your 2015 paper. So 2015 paper, as I said, again you have a structure to draw in paper. So they've given us, draw the structures of the following oxoacids of phosphorus, which is done under video number 98. Please go to the playlist and watch that video. And XCF4, which is done under compounds of xenon. That is under video number 52. Let's read the question. Again, the same question they've given us. Account for the following. I've been doing the same question in different board papers. So what do they give us? Interhalogen compounds are more reactive than pure halogens. That means interhalogen compounds, what are they represented with? X prime, isn't it? This is what is your interhalogen compound. The larger this is an element with a smaller element. If I say iodine and Cl, larger atomic radii iodine combines with Cl, like that, larger and smaller. Done. And with pure halogens means it is X2, like X and X. Both are similar, X2. Then they asked us, why is it more reactive? Simple, isn't it? First important thing, when I speak about interhalogen compounds, they're more reactive. First concept is difference in electronegativity. Here there is no difference in electronegativity, both are similar atoms. Here, first, difference in electronegativity. When there is difference in electronegativity, what will happen to the bond strength? Or the bond strength will be very, very weak, isn't it? So, X prime bond is weak. When it is weak, automatically, hence reactive. Then X2. Simple, over. Let's see this. N2 is less reactive at room temperature. Okay. So what is basically nitrogen? When we speak about nitrogen, I have to speak in terms of atomic radii. When I speak about atomic radii, immediately you have to speak about the bond dissociation enthalpy. When the radii is very, very small enough, how much should I use energy? The bond dissociation energy, should I use more energy or less energy to break the bond? I require more energy. Yes, so room temperature is not possible. That's a concept. N2 is less reactive at room temperature. First, write down, nitrogen has smaller atomic radii. Okay, if smaller atomic radii, what is more? Bond dissociation enthalpy is high. If bond dissociation enthalpy is high, what will happen to its reactivity? Hence, less reactive, because every time I can't apply so much of energy, hence less reactive at room temperature. So every time I can't apply so much of energy to break the bond. So that's why they are that. Now reducing character of increases from ammonia to bismuth. I did this in video number 25. So I already explained this. Remember, the main reason for me doing the board papers is I'll be giving you the keywords which you should write in the answer. That's the main concept. So all these are keywords. Don't write big chapters and lessons or histories. Only thing is keyword, smaller atomic radii, bond dissociation enthalpy is high. I require a lot amount of energy, so it is less reactive. Every time I can't apply energy to break the bond and make it reactive. So nitrogen is less reactive. This is how you should write. So that's the main reason for me to doing the board papers. Right, let's come back and see the part B. That is a choice question of 2015 paper. What do they give us? Which poisonous gases evolved when white phosphorus is heated with sodium hydroxide, and write the reaction, they said. Okay, basically I did this video number 36. The poisonous gas which is released is phosphine. So please watch that video. I've clearly explained step by step every reaction. So phosphine is a poisonous gas. Watch that video. That is video number 36. So which noble gas has the lowest boiling point? Helium. This is understood. Then F2 is stronger oxidizing agent than chlorine. 88 video number. I did that. Next, what happens when H3PO3 is heated? Okay, simple. H3PO3, when it is heated, it breaks up. Suppose if I take 4 moles of this, when it is heated, it will break up and form 2 products. One is phosphorus acid forms phosphoric acid, H3PO4, and phosphine. Done. Now 3 moles if I write. Yeah. Let's see, 4 3s are 12. 3 3s are 9, 10, 11, 12. Okay, phosphorus is 4 here. So let's see. Yeah, phosphorus 3 plus 1, 4 here. Oxygen 4 3s are 12 here, 4 3s are 12. Done. So H3PO3, very famous question. This is H3PO3. When it is heated, it will break up into H3PO4 and phosphine. So try to pick up 4 moles here. When you balance, you get 3 moles here. So complete the following reaction. PbS plus O3. Oxidizing properties of ozone. Everywhere oxidizing properties are very important. Please practice those. I did that in video number 68. Watch for the answer. Let's come back and solve your 2014 paper. So 2014 paper, again they've given structures. So my request is please practice the structures. What structures should you practice for the board exam? You are supposed to practice structures of xenon compounds, which I already did. You're going to practice structures of oxides of nitrogen. Then you have structures for oxo acids of sulfur, phosphorus and halogens. I did for all, right? Please practice them. Now all the 5 sets you need to memorize. How many ever times you can practice, please practice it. Let's come back and solve the first question. Now basically, reaction of phosphorus with water. It is a preparation method for preparing phosphine. Remember. So how should you do? Try to pick up 6 moles. Okay. Try to write 6 moles first. When you write 6 moles, what happens? I said this is a method for preparing phosphine. PH3 comes out. PH3. Now how many we are left with? We are left with 3 more hydrogens. So the leftover H3. Okay, H3 PO2. Okay, now observe carefully. 3 moles. Now observe 3 hydrogens here, 3 hydrogens here. But total when I count, 3 3s are 9, 10, 11, 12. 6 2s are 12. Phosphorus, 3 phosphorus and 1 phosphorus P4. And water molecule, oxygen, 3 2s are 6, 3 2s are 6. Balanced, isn't it? So this is called phosphine. And this is called hypophosphorus acid. Hypophosphorus acid. Phosphine, because I basically took 6 moles. Careful. So phosphine, the leftover is 3. The H3PO2, that is hypophosphorus acid, not phosphoric acid. Done. Now when I have to see this reaction, again simple, just see XeF4 plus XF2. What will happen? XeF6. Isn't it? What else is left? We're left with oxygen. That's it. Simple addition reaction. Right, let's come back and start with your 2013 paper. So in 2013 paper, what they ask, what happens when PCl5 is heated? So simple reaction, when PCl5 is heated, it dissociates into PCl3 plus Cl2. There's nothing big logic in this. Dissociation. Now the second question, H3PO3 is heated. So I did the same question board paper 2011. Watch that video. Now I'm going to erase this because I need answers for this part of the board. Done. Let's come back and start with the next question. What do they give us? Give reasons for the following. Every time there is give reasoning question compulsory. What do they give me? Bond enthalpy of fluorine is lesser than Cl2. Okay. So bond enthalpy, that is high. The energy to break the bond is lower, it seems. Why is it lower? When I have to speak about fluorine and chlorine. Atomic number, this is 9, isn't it? 1 is 2, 2 is 2, 2p 4. Done. So 4, 5, 6, 7, 6, 7, 8. Okay, 2p5 it is. Yes. Done. So in fluorine, first important thing is atomic radii is less. Okay, done. And when atomic radii is less, one concept. Next concept is, but though atomic radii is less, when I see the configuration of this fluorine, right, 1, 2, 3, 4, 5. This lone pair of 1 fluorine, one more lone pair of 1 more fluorine. So there are a lot of electron, because the size of the radii, that atom is very small. So the electron repulsion, 1 fluorine, 1 electron, the other fluorine, 1 more electron. So what happens here? Electron repulsions increase. When electron repulsion increases, bond enthalpy automatically, with less energy only I can break the bond, because already it is repelling. When it is repelling, it will open up the bond. So simple, isn't it? So hence, so bond enthalpy is lower for fluorine compared to chlorine. This is what is important. So that is your answer. Done. Yes, let's come back and see. pH3 has a lower boiling point than NH3. Okay, I did this video. I'll be again writing the keywords. Let us erase this part of the board and then come back to that question. Okay, what did they give me? They've given me pH3 has a lower boiling point than NH3. So what is the difference between pH3 and NH3? In NH3, when I have to see, and pH3, whenever you're speaking about bond boiling point, speak in terms of type of the bond. In NH3, what type of bond we have? We have intramolecular hydrogen bonding, right, which is strong enough. When there is intramolecular hydrogen bonding, what will happen? The boiling point automatically BP is high, but in pH3 it is less. Why is it less? Here you have weak van der Waals forces. Why weak van der Waals forces? Because the atomic radii of phosphorus is high, larger than this. So weak van der Waals forces, hence BP is low. So keywords are very important, right? So this is the keyword: intermolecular hydrogen bonding. Intermolecular hydrogen bonding. Okay, intra means I've written between two different, means two molecules rather. I'm not saying inside. So what should I write? I should not write intra, isn't it? Intra means inside the molecule. It is between. Intermolecular. Be careful. Intra is within the molecule. Inter is between two molecules. This is inter. This is intra. I'm sorry for that. So intermolecular hydrogen bonding is there. So boiling point is high. Weak van der Waals forces, hence boiling point is low. That's it. Next, draw the structures again. BRF3, I did it in video number 97. HPO3, your oxoacids of phosphorus in video number 98. And XCF4 under video number 52. Please watch the videos for the information. Right. Let's come back and solve the 2012 paper. What did they say? Draw the structure, draw the molecular structures of the following. Okay, as I said, the structures are compulsory asked in every paper. And so I've done this XCF6 structure in video number 52. And this structure, there is oxoacids of sulfur in video number 99. Done. Let's come back. Explain the following observations. NH3 and NF3 have dipole moments which are of opposite direction. A bit different question. It's easy to answer. Let's see. So they've given me NH3 and NF3. Okay, done. First, let us draw the structure. NH3. Okay, lone pair is already there. NF3. Okay, now what actually is a dipole moment? When you represent a dipole moment, how should the arrow be? The arrow should follow. How should this point be? When you ending the arrow, whichever is more electropositive, that arrow will go towards that. Okay, right? Here, just observe carefully. Whichever is what did I say? Yeah, more electropositive, that will go towards that arrow. Now, in this case, we are going to see this electronegativity value. Yeah. So now what happens? Hydrogen is less electronegative than nitrogen. So the arrow just points this. Now, in this case, when I have to see, the arrow points in this direction. Now, see, this is more electronegative. Done. This is electropositive. Done. So the arrows are pointing towards in this direction, and here the arrows are pointing downwards. So just write down, this is more electronegative, hence it drags the electron density. This is more electropositive, so this goes down. Done. So because of this, the dipoles are opposite direction. That's why they have dipole moments which are of opposite direction. Done. The next question, all bonds of PCl5 are not equivalent. I did this in 2009 paper. And this question, sulfur in vapor state exhibits paramagnetism. I spoke in terms of antibonding orbitals in vapor phase. So I did that question in 2008 paper. Right, let's come back and solve your 2011 paper. In 2011 paper, Let's see the question. Explain the following. NF3 is an exothermic compound, whereas NCl3 is not. I did the same question in 2010 also. Please watch that video. Next, fluorine is most reactive of all the 4 halogens. So I did one video where I explained why are halogens more oxidizing properties and why is fluorine more oxidizing than chlorine. Okay, that video explains you the concept. But here, if you have to write only in terms of fluorine, why is it more reactive? The keywords which you should remember is, see here, first keyword, it is more electronegative. First keyword. Second, it has least or low bond dissociation enthalpy, BD, bond dissociation enthalpy means required to break. I did that video, please watch, you'll understand the concept. I am writing the keywords only. Done. Second important, third important, high hydration enthalpy. High hydration enthalpy. The last one would be electronegativity is covered. So when the electronegativity is more automatically your this bond dissociation enthalpy, when I see it is only 158 kilojoules per mole. Then high hydration enthalpy you can also write in terms of lower electron affinity, attracting power. Done. With these factors we'll explain you, but I'm not explaining it here. Watch that video, you will understand under the heading why is fluorine more oxidizing than chlorine. I have shown you Born-Haber cycle, I've shown you Gibbs free energy there, I've shown you electrode potentials also. Watch that video, you'll understand why am I trying to explain this. Then after this, complete the following. This reaction I did it in video number 84, and phosphorus, preparation of phosphine in the lab, preparation of phosphine, which is done under video number 36, and chlorine interhalogen compounds, which I did it in video number 97. Let's come back and start or finish off your 2011 paper with this question. What do they give us? Account for the following. Acidic strength decreases in the order. Okay, I've done one video where I've explained you the acidic strength, boiling point, and the reducing character. Let's come back and see this. How to write this answer? They've given acidic strength. That means release of H plus ions. Done. So let's start the answer like this. What are you finding? All hydrogens are similar, but only difference is phosphorus, sulfur, and chlorine. So what are these elements? These are third period elements, isn't it? So what happens in third period when I have to speak? Done. First comes phosphorus. The electronegativity of phosphorus, right, is lesser than sulfur, lesser than chlorine. This is the electronegativity. Now, when the electronegativity is lesser, let us write the hydride form of that. So pH3 lesser, H2S lesser, HCl. Now, what is the reason? Let's see. Now, I said the electronegativity value. Okay, this is En value. Which En value? Increasing order. So, increasing order of En value. That means when I have to speak, phosphorus is less electronegative compared to chlorine. So, it is increasing. Phosphorus electronegativity is less than sulfur. Sulfur electronegativity is less than chlorine. Now, when I have to speak in terms of acidic nature, release of proton, now say if electronegativity is very less for phosphorus, the bond between these two is weaker. If it is electronegative, highly electronegative, so hold the bond together in this case. But here when electronegativity is lesser, the bond holding capacity is weaker, means the bond is weaker. When the bond is weaker, it is easy to release the protons. When it is releasing the protons, automatically the acidic strength is high, right? Done. Let's come back and write. So how should you write the answer? So I'm erasing this question. Yes, and let me write the answer. Okay, let us write the answer in this term because I don't have place. I'm using this part of the board. What should you write? Start your answer like this. First, write this. Phosphorus electronegativity is lesser than sulfur. It is lesser than chlorine. Then in hydrides, pH3 is lesser than H2S, is lesser than HCl. After writing this, write the reason. What is the reason? As electronegativity difference or electronegativity is less, electronegativity of phosphorus is less, the pH3 bond, okay, pH also you can write, bond is weaker compared to what? Compared to HCl. When it is bond is weaker, it is hence less acidic. It can easily donate H plus proton, isn't it? Hence less acidic, then HCl. So this should be the first reason. This should be the second reason. You'll get full marks for that. Done. So let me erase this and write the second question. What do they give me now? They've given me, they've asked me here, the tendency to form pentahalide decreases down the group, they said. Okay, pentahalides of group 15, they said. When they say group 15, try to write the elements. I'm writing this answer here. Group 15 elements, what are they? Nitrogen, phosphorus, arsenic, antimony and bismuth. They say tendency to form pentahalides. When I go down the group, the tendency to show +5 oxidation state. That is nothing but pentahalides. What if, for example, BiCl5 pentahalide. It can be generally BiX5. This is not observed the same. Why does it decrease? Because PCl5, NCl5 or all these is observed, but here when I go down it is decreasing. By simple reason, you have to write the keyword in this. Take this element because they have asked it is decreasing down the group. Pick up bismuth. So what happens in bismuth? This is the reason. Electronic configuration, if I have to write, xenon 4F14 5D10 6S2 6P3. Now what is happening? If it can easily donate these 3 electrons, it form BiX3, but what happens when it comes to losing these 2 electrons? This S electron shows inert pair effect. It is reluctant to participate in bonding. So what is happening here? Bi can form BiX3 compounds, but due to inert pair effect of S orbital, due to inert pair. You already know what is inert pair effect, isn't it? I have explained for the grade 11 students also. Reluctance of S electron to participate in bonding. So due to inert pair effect of S electron, it does not form BiX5 compounds. That's it. This is how you're going to write the answer. So this inner word, this is important. This is the keyword, inert pair effect of S electron. That's why if this is not donated, how can it show 5 electrons? See here, 3 + 2 5. It can't show, isn't it? So that is the concept. Done. This question is over. Now complete the following. So they've given one question, that is your P4SO2Cl2 sulfuryl chloride, not thionyl chloride. I did this in video number 43. Next, iodine. This is the oxidizing property of nitric acid, which I did in video number 33. Please watch the video. Done. When I have to show the hydrolysis of XCF2, just see, pick up 2 moles of this, pick up 2 moles of this. Simple reaction it is. So I'm doing the hydrolysis. First, immediately, first bond Xc is going to dissociate. How many moles? Here I've taken 2 moles, so 2. After this, your HF is going to form HF. How many HFs here? So if I have to see, this is 2 2s are 4, isn't it? So 4 HF. What else is left? Oxygens are 2. So oxygen gas. That's it. So these are the reactions of 2011 paper. Back and start with your 2010 paper. Done. In 2010 paper, again they have 2 parts. There is one more leftover part with this. Let's read the question first. Draw the structures of white phosphorus and red phosphorus. Which one of these 2 types is more reactive? So I did one video, differences between white phosphorus and red phosphorus with structures. That's in the video number 35. Please watch the video for the information. Next question. Complete the following. So this question, hot and concentrated, that is reaction of chlorine with hot and concentrated, that is disproportionation reaction. Very important question of chlorine. With hot and concentrated, cold and dilute. I did this video in the video number 90. Watch the video for the information. Next, with hydrolysis of xenon fluorides. This also is done under video number 51. Please watch the video. You will have a clear explanation of the concept. So let's come back and do the next part of 2010 paper. Okay, now let us come back and do your 2010 paper, the remaining part. What do they give us? Account for the following. How do you account for the following? They've given us the value of electron gain enthalpy with negative sign for sulfur is higher than that of oxygen. Okay. Now the concept of electron gain enthalpy, I did in one video, that is video number 88. I've clearly explained what actually is electron gain enthalpy. Electron gain enthalpy is basically the amount of energy released when an electron is added, or 1 mole of electron is added bonded to a gaseous atom. That is what I explained in that video. Please watch that video, you'll understand the concept. First watch that video and then come back to this question. They said already it is negative, that means energy is released. So they said the value of electron gain enthalpy with negative sign for sulfur is higher than oxygen. So when I have to see between sulfur and oxygen, which atom is larger? Yes. Hydrogen, helium, lithium, beryllium, oxygen, atomic number is 8 and sulfur atomic number 16. So which has more number of shells? Sulfur. So simple, isn't it? Sulfur atomic size or radii is larger than oxygen. So when atomic radii is larger, I can easily add the electron into the sulfur atom. When I am trying to add the electron into the sulfur atom, obviously the amount of energy released also would be more, that is negative electron gain enthalpy. So right now sulfur atomic radii is larger than oxygen, hence higher negative electron gain enthalpy values. That's it. This is the question. This is the concept which the examiner wants you to write, because you have to express in terms of atomic radii. This is the word which you have to write. Done. Let us come back. NF3 is exothermic but NCl3 is endothermic. So NF3 is exothermic molecule. Exothermic means what? Energy is released. Done. When is an energy released? When the bond between nitrogen and the particular halogen is strong enough. When it is strong enough, it will hold the molecule or the atoms together, and automatically when I am trying to break the bond, the energy will be released. Once again, when the bond is stronger, more amount of energy is required. When the more amount of energy is required, that amount of energy means that when it breaks up, the energy is released, isn't it? Now write down why is this exothermic? Start writing in terms of NF. NF, in NF, what is the concept? The atomic size. First let us write in terms of atomic radii is less. Then after atomic radii is less, NF bond is stronger. When atomic radii is less, and what also should also be less? Electronegativity is more. Okay, atomic radii is less and electronegativity is high. This is very important, right? So when these two concepts are there, what will happen in NF bond? NF bond is stronger than NCl bond. So when this is stronger, automatically it becomes an exothermic reaction, isn't it? Hence NF3 is exothermic compound. Okay, this is because of the space constraint. I am writing it very small. Right. Again, speak in terms of atomic radii, keyword. Speak in terms of electronegativity, keyword. When these two are there, automatically the bond becomes stronger. When the bond becomes stronger, automatically it is exothermic reaction, and this is endothermic. Energy is absorbed. Done. For the last question, ClF3 molecule has T-shaped, not trigonal planar. Thus I did it in video number 97. Watch the video. I've also drawn the structure of BRF3 as well as ClF3. Right, let us come back and start with your 2009 paper. So 2009 paper, they've given two questions. Again, there's a choice question. Let us do that. So 2009 paper, again, they've given structures as well as complete the following. And there's a reason also given. All together, they've combined, and very nice, interesting paper this is. So in 2009 paper, they've asked complete the following reaction. So I did the hydrolysis of xenon. Again, I'll be doing it here. Just see. Now, whenever you find such reactions, simple, try to pick up 2 moles of this. It's easy for you. Remember, so the first thing, HF would come out. Along with that, there's a cleavage of the bond here. Xenon also would come out. Done. After this, what else is left? Oxygen combines to form oxygen gas. So here 2, so 2 xenons. Here hydrogen, you have 2 2s are 4, so try to make 4. Then fluorine is already 4, oxygen is 2, isn't it? This is the balanced reaction. Now next question, phosphine plus Hg mercury chloride. I did it in video number 38. Now I draw the structures. Both the structures are done under 99 in video number and 100. Next, come back, account for the following. Ammonia is a stronger base than phosphine. I did this in video number 25. Please watch that video. Next, sulfur has a greatest tendency for catenation than oxygen. This video also was done under video number 64. Next comes fluorine is a stronger oxidizing agent than chlorine. So this is done under video number 89. So almost all the questions I have covered. That is the reason I'm asking you to go through the videos carefully. Let's come back and do the leftover part of 2009. Right, let's come back and do the part B of a 2009 paper. What did they give us? Explain the following. In the structure of HNO3, okay, the NO bond is 121 picometer and shorter than NOH bond is it. Okay, so basically when do we call something is shorter? We have a criteria: single bond, double bond, triple bond. Now when I compare these two, what do you observe? This has a double bond character and double bond O. Now this has a single bond, so obviously, isn't it? So why is this shorter? Just write the answer. Due to double bond character in NO bond. That's it. If you write this word, due to double means due to double bond character, no bond. That's it. This explains the whole concept. And then let me come back to this. All PCl bonds are not equivalent in PCl5. Okay, the question is, in PCl5, all are not equivalent. Why? So when I have to draw the structure of this, just see phosphorus in the center. You have 5 chlorines. How are they arranged? 1 chlorine, longer. This is also longer. These are called axial bonds. The leftover 3, 1 is distributed here. 1, 2, and 3. I already did this video. Please watch that. And you're joining them. Okay. Join them in this way. Now, these are called equatorial bonds. Axial bond length is, when I see this, it is 242 picometer and equatorial is a 202 picometer. Now they're asking why is it different? So simple. What should you write? That in axial bonds there are electronic repulsions. Because of this electronic repulsions, the bond length has increased and automatically you're finding that difference between two. How should you put in that word? Try to draw the structure first and write the answer. Axial bonds are longer than equatorial bonds. Why? Due to repulsions. A lone pair of repulsions. That's it. This is your answer. Then draw that structure and draw this data also, please. This is also important. Next question. ICl is more reactive than I2. Okay. ICl is basically an interhalogen compound. Combination of two, more reactive than iodine. So what is the most important thing? It is more reactive. Why? Due to the difference in electronegativity between both. Here in I2 there is no concept of electronegativity, isn't it? Two similar atoms. Here why is ICl more reactive? Your answer should be due to electronegativity difference between iodine and chlorine. So because of that there is a pull in the electron pair and it automatically becomes more reactive. Let's come back and start solving your 2008 paper. Again, just see you have a structure given in 2008 paper also. So remember, structures are very, very important in P block chapter. Compulsory, you'll be asked to draw a structure. Now, let's see this question. They've given us assign a reason for each. Now, basically, we have studied the concept. Let us see how to write the answer. What do they give me? They've assigned means just give a reason for the given question. What did they say? Ammonia is a stronger base than phosphine, they said. Okay, simple. Try to divide the page like this. Your ammonia is here, phosphine is here. They're asking to write the reason. So basically what happens in ammonia, when I see this ammonia or nitrogen, the lone pair of electrons they're directly they're linked to nitrogen. They're concentrated on this nitrogen. Done? Yeah. So in phosphine, what is happening as we go down the group, the size of atom increases. When the size of an atom increases, phosphine also has lone pair. But what is happening here in this case, the electrons are delocalized. They're spread all over because the size of this atom increases. So the spreading of the electron cloud increases. So that means which is stronger base, which can hold that electron. So remember once again here electrons or lone pair of electrons are directed. They are directed towards nitrogen. Done. Second, here lone pair are delocalized. Why? Due to increase in atomic size. AS means atomic size of phosphorus. The first one. Second important thing, nitrogen doesn't have any d orbitals. Correct? So does not possess d orbital. But in this case, phosphorus has d orbital. That's it. So this is the reason for ammonia acting as a strong base, because the whole electrons are concentrated on that. Now here it is spread. You can just finish up your answer with 2 reasons. Now here they've given me sulfur is in vapor state exhibits paramagnetism. I did one video showing that why is oxygen paramagnetic in nature. I did one video, please watch that. In the same way, just like oxygen, sulfur also has, when you draw your according to your orbital theory, that is bonding and anti-bonding molecular orbitals, sulfur, when you draw that, you get an anti-bonding orbital. What do you say? ABMO, a anti-bonding orbital, that is here pi star. In that you find unpaired electrons. You can draw the structure, take sulfur and draw the structure, bonding, anti-bonding, bonding, anti-bonding in your grade 11th which you have drawn. There in anti-bonding orbital you get unpaired electrons, hence it is paramagnetic in nature. So what does the examiner wants you to write? This is your answer which the examiner is expecting. Where do you find the unpaired electrons? If the unpaired electrons are present, automatically it is paramagnetic in nature. This is also done. Next question, draw the structure of XeF4. As I said, watch it for in video number 52 where I have drawn all the structure of xenon compounds. So here they have given one SF4. Simple, it's nothing. Sulfur 1, 2, 3, 4. Okay, I'll make everything together. And a lone pair. Why did I draw this? Sulfur is 16 atomic number. So let's see. 1s2, 2s2, 2p6, 3s2, 3p4. Done. So this is shade and the leftover is shown in the pair. Let's see here, 4 and 2. Done. So this is your 2008 paper. Try to write the reason clearly. The keywords are important. Then writing or drawing the structures are important. Right, let us come back and start with the 2008 paper. So in 2008 paper only, this is a part B question. Let's see. What do they give us? Write the chemical equations for the following. So chlorine reacts with hot concentrated sodium hydroxide. I did a video with cold and dilute conditions as well as hot and concentrated conditions, and a video number 90. Please watch that video. I've given a clear explanation for that. Next one, orthophosphorus acid heated. Okay, simple. There's nothing in this reaction. You see here, orthophosphorus acid. What is this? H3PO3 orthophosphorus acid. When you heat this, simple, it gets converted to higher oxidation state, that is phosphoric acid. H3PO4. Along with that, you also get phosphine. This is basically one of the preparation of phosphine. Orthophosphorus acid on heated gets converted to phosphoric acid plus phosphine. So when I have to balance, let me take 4 and here also 4. That's it. Simple reaction. Let us put this in a box. Next, what do they give us? They've asked us PTF6 and xenon are mixed together. Okay, I did this video also under video number 48. Watch that video for the information. Next, there is an OR question. Complete the following. Complete the following reactions are quite common in P block. As I said, structures are also important, and complete the following. So I did this question in video number 36, and this question where I said reaction of copper with sodium hydroxide results ammonia, that is numbered as video number 90. Please watch that video. Let us come back and do this. F2 plus H2, nothing. Simple. See, when you are taking adding water to a halogen, first important it will break up into F minus. Then this breaks up into O minus, O2, oxygen, because I'll tell you why. Because I'm going to take 2 moles here. Here also I'll pick up 2. When I pick up 2 oxygen, O2, isn't it? Done. So what do we have? 2 2s are 4. 4 H plus. Correct. Now, what else do you have? Fluorine is how much? 4. This is. Try to take 2:2 here, so that this will break up from 0 to -1 state. It has gone. I have taken 2 moles, so 2 2s are 4 fluorines here. Here also I have taken 2 moles because oxygen gas comes out. So this becomes, hydrogen becomes 2 2s are 4, 4H plus. So this is your reaction. Right, now let's come back and start with your board papers. That is your 2007 paper. So in 2007 paper, basically the weightage for the chapter is only 5 marks, 2 marks question and 3 marks question. Let's see, they've given us write the structures of the following species. So the structures in P blocks are very, very important. That is the reason I've done 3 videos, that is 98, 99 and 100. All the 3 videos are done at the end so that you will practice it properly. So the structures are given, which is number for H3PO2. I've done a video on which is numbered as video number 98, and H2SO5, that is oxoacid of sulfur, under video number 99. Please watch the video and practice the structures. More number of times you practice the structure, it's easy for you to memorize. Done. Let us come back to understand 3 marks question. Basically in 3 marks question there was one more question here which is not related, not there in your syllabus also. There was some other chapter clubbed together. Okay, let us solve these 2. How would you account for the following? Account for the following means give reason type questions. So whenever you see the word account for the following means they want you to reason the question. What do they give me? HF is much less volatile than HCl. So that means less volatile means what? It will not vaporize faster. Right? So what should you write? You have to start your answer in this concept. What is the difference between this? Here hydrogen and hydrogen are common. What is different? Fluorine. So start writing. Fluorine is, okay, more, we will not write high, more okay, let us write this is an answer. It is more electronegative than chlorine. Okay, this is my first condition, first reason. If it is more electronegative than chlorine, what will happen to the bond between them? HF bond is stronger and it forms a strong hydrogen bonding. And stronger in what sense? Stronger hydrogen bonding. Because between hydrogen and electronegative atom is hydrogen bonding, isn't it? So when the hydrogen bonding is stronger, will it be volatile? Can it vaporize immediately? No, isn't it? Hence, less volatile. That's it. You have to write only 2 lines which are relevant to the answer. Don't write big paragraphs. You will not find time to finish off the 70 marks paper. Start in terms of F. Start in terms or end in terms of hydrogen bonding. Stronger in HF compared to HCl. You can write that also. Compared to HCl. Hence less volatile. That's it. Now let's come back and see the next question. I've done this concept also, interhalogen compounds. So but let us see how should I write the answer. Interhalogen compounds are strong oxidizing agent. So basically whenever I speak about oxidizing agent, see the answer how to write. Now a halogen or X and X, what is this? This is between 2 similar halogen atoms. Done. So these are good oxidizing agents which we have already seen. I've done a video saying that why are halogens good oxidizing agent? Because of the bond dissociation, low bond dissociation enthalpy, electronegativity and all these factors. In the same way, when I have to see the bond in interhalogen compounds, that is X and X prime. So this bond also is very weak. When it is weak, obviously it acts or it tends to act as an oxidizing agent. It can show that property. So the bond, okay, very weak bond, hence are good oxidizing agents. That's it. That's a relevant answer. So write down X and X bond, good oxidizing. Compared to that, in interhalogen, this is very weak. So I can easily break the bond and act as good oxidizing agents.